Okay. So what type of reactions are we talking about here? You guys have just done all this predicting and classifying, right? You guys were predicting synthesis reactions, decomposition reactions, combustion reactions, but this lab, what type of reaction were you doing? You had zinc plus HCl, and you had copper plus HCl. What were the states of your zinc and your copper? Solid. What was the state of your HCl? Not a liquid. It was a solution with water. It is aqueous. So, when you have to classify these two reactions, what do you classify them as? There you go. You got it. Say it louder. Single replacement. Take a look. A plus BX. What does it react to produce? AX plus B. A and B are switching places. Single replacement. Now, take a look at this activity series. You have a whole rank of metals based on how reactive they are. Take a look at zinc, take a look at hydrogen. Which one is more reactive? Here's zinc. Here's hydrogen. Which one's more reactive? Zinc. The one higher up is more reactive. So zinc is able to knock hydrogen off of the Cl and produce zinc chloride, aqueous, plus H2. And what's your state for H2? What did you guys see in the reaction? Yeah, you guys saw bubbles in your reaction. You guys saw that H2 being formed. And what happened to your penny? What? I can't hear you.
It got brittle.
Brittle, but what made it brittle? It was hollowed out. What was on the inside of your penny? Not black powder. What was on the inside of your penny? Zinc. The zinc was on the inside of your penny. The copper coated the zinc, but it was the zinc that reacted with the hydrochloric acid. So your penny got brittle because the hydrochloric acid reacted with the zinc that was on the inside of your penny. What happened to the copper? Did the copper react with HCl? You should have saw NR. What's NR? No reaction. So the copper should not have reacted with the HCl. Why would the copper not react with the HCl? Take a look at your activity series. Here's your hydrogen again. Where's your copper? Your copper is less reactive than the hydrogen. Is the copper able to knock the hydrogen off the Cl? No. That's why we don't see a reaction with the copper and the HCl. All right, Pb plus ZnCl. So we can see it takes the form A plus Bx reacts to produce Ax plus B. Hey, are you paying attention? So, the question is does lead switch places with zinc? Well, take a look at reactivity series. Here's zinc. Here's lead. Which ones are more reactive? Zinc. So in this case, lead can't knock zinc off the Cl, so no reaction will take place here. Now, you guys have already seen this other one. Zinc plus HCl. Zinc is higher than the hydrogen on your activity series. So because of that, it knocks the hydrogen off. You get zinc chloride. This is aqueous in state plus H2 gas. All right, take a look at magnesium bromide. What's the formula for magnesium bromide? Mg is +2. Bromine is a halogen, so it's -1. You need 2 bromides to balance out or make a neutral compound with your magnesium. Plus Cl2. What's the problem here? They're halogens that you would look to switch places with one another. You don't have 2 metals, so you're not looking at the activity series on the metal side. Look down at the very bottom, though. You have a whole activity series for your halogens as well. So here, F2 is your most reactive halogen, I2 is your least reactive halogen. What do you notice about that order? Yeah. Say it louder.
It's the thing, the upside down thing, not
What I was going for is it's the same order on the periodic table.
That's what I said.
Sort of. So yes, they're all diatomic, but that has nothing to do with the fact that it's the same order on the periodic table as the activity series. So fluorine is your most reactive, iodine is your least. Now, what's more reactive, Cl or Br? So will this reaction occur?
Yeah.
Yes, it will. MgCl2 plus Br2.